We will be starting the session now. So I will start with giving brief introduction for Dr. Mustaq Ahmed. So Sir is Associate Professor and Head of Computer Science Department at MNIT Jaipur. He is working for past 26 years. He did his PhD from MNIT in 2012. He is teaching courses on advanced computer architecture, embedded system design, VLSI algorithms, wireless sensor networks, distributed computing, etc. His research areas are high-performance computing, wireless sensor networks, cloud computing, embedded system design, and advanced computer architecture. He has published more than 80 peer-reviewed journals and conference papers. He has 2 patents and has guided 6 PhD and presently guiding 7 research scholars in the area of parallel compilers, high-speed overlay networking, fault-tolerant systems, wireless sensor networks, multi-core, multi-core architecture, cloud computing, and blockchain. He is a fellow IE, life member of ACM, life member of ISTE, life member of ACCS, member of IEEE, and member of IENG. So handing over to you, sir.
Hmm. So good morning, all of you. Uh, 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 Previously, in the yesterday, we had discussed about the basics of the cloud computing. Pertaining to that, the various type of that models that are existing. In order to make the various type of the task applications that need to be mounted and to be worked upon, the challenges are there. That how those type of the scenarios can be established and how that can be maintained in such a way that the system should work and there should not be any inconsistency, anomaly, or that overburden in the systems, and that may create the problem. Pertaining to that, the challenges are there. So in that case, the varieties of the techniques are there, or that platforms are there, which are inherently having those type of the features that need to look into the balancing of that task that need to be shared with the system. So pertaining to that, yesterday evening we had shown you that a simple type of that simulating environment where the simulation machines can be established and the cloudlets or the task that can be given to them, keeping in mind that the balance should be maintained. Pertaining to that, the challenges are there as per the need and requirement for for getting the multiple task, or if in a period of span of the time constraint base, certain task that may arrive. In that case, whether that system would be able to handle that or not. So in that case, the challenges are there pertaining to that, the availability of the resources and its requirement. If that requirement can be made with that availability of the resources, in that case, how and best and optimal way that we can schedule those type of the tasks. Pertaining to that, the challenges are there. In this, the existing type of the algorithms which are available in the books and the work that has already been done, and the other part that we have also done in order to make the better optimization way and compared to the existing algorithms. So that part that I shall cover over here. So in this, as the content are taken from the ISC and the various books that are available, and in this, the near to that approximate approach that requires to be used in order to um, optimize the performance of the systems while assigning those type of the tasks. So while assigning the task, the challenges are there that having that virtual machine. So the constraint are 4 or 5 for that. That the size of the memory available of the disk space, the speed of or the bandwidth of the channel through which that data would be transmitted, and that the core component available with that system, so whether that would be able to do that. So in that case, one machine based on those type of that hardware or the resources available can handle the multiple number of the tasks. So in that case, there could be the mechanism either in that round robin method for first the shortage of first or first come first serve type of that basis. So and in that the dependency, if it has been there, and the scheduling of that, the task scheduling can be done in such a way that the resources should be fully optimized with that minimal number of the time stamp, so that the outcome can be achieved in a minimal stimulated time. So pertaining to that, the challenges are that the controller who has to assign those type of the tasks, so the DC would have to look into those type of the tasks, its complexity or its natures, and assign them to the machine. And pertaining to that, multiple ways and the techniques that are being explored to optimize the performance of the system. So this particular talk is related to that. Pertaining to that, in the evening, we will give the demonstration of those algorithms which are being discussed over here. So normally is that when we talk about the approximation algorithms where the constraint pertaining to this based on that the large number of the input and the uh, n NM, NNM queuing mechanism where the multiple node and multiple servers are there, so which requires to handle those type of the situations. So in that case, this becomes a NP hard type of the problem. So in that case, we requires to look into that what sort of the mechanism should we apply based while looking on those type of the constraint, and using that the optimization of the resource can be there, the minimum time spent that should be maintained, and that the resources should not be overburdened, or some of that resources they may not, it should not happen that they may not ever be used. So in that case, the algorithms which are heuristic in nature and having those type of that dynamic options available, so where certain of that would give you that assurance that at least it can be reducible so uh, to the NP complete or in the polynomial time that the solution can be maintained. So in that the scenario is that the certain part of that would be fixed and the other part that has to be managed. So likewise that the reducing of that complexity can be maintained. So pertaining to that, we require to look into that, the amount of the job which are to be assigned to the system. So we assume so that the size of the job may be varying and the amount of the times to be used by that job would be varying, and based on that availability of the resources that a job has to be scheduled. So in that the total amount of the times based on that would be that the amount of the task that has to be given to the system. So let us say I do have this certain number of the task with that varying interval which are arriving, and in that case, the resources are available with me. The three resources are available with me. Based on that, this task need to be scheduled. So let us say that this task, if that task which has been completed and the next task which is available, so that can be easily assigned to them, and other tasks which ought to be arriving time for that or interval may be varying. In that case, that has to be assigned to the other machines while the first one is already been engaged. So in that case, the next availability of the machine has to be explored. And if that has been there, in that case, the scheduling can be done. So in this case, the challenges are there that if that all the machine which is already been in the burden and the resource constraint are there, that only that machine can perform those type of tasks. In that case, we require to establish another table pertaining to that number of the virtual machines to whom that task is need to be scheduled, and that the scheduled task has to be in the waiting state once that machine gets uh, uh, free. In that case, it has to come from this the waiting list to the current assigned list and the task can be delivered. So in that case, the maximum load that can be the threshold need to be assigned that this much of that load that machine can handle. And pertaining to that, the throttle-based algorithms that I shall discuss over here would give you that the clarifications in that how and easy we can manage that. So pertaining to that, the task, number of the task, number of the machine, and that jobs that can be assigned. So in that case, the task would become easy. So likewise, in that round robin fashions or the selective time span that can be assigned, or that entire time is spent for that can be assigned to the multiple number of the machines so that the task can be completed. So this would depend on that availability of the resources, availability of the machines, and the task which can be distributed over the machine. So keep this in mind that this job or the task that are interrelated with each other. So pertaining to that, we require to look into that in that the infrastructure as a service that the resources are available. Pertaining to that, the jobs which are required to be computed, the well set up establishment that is there, and the symmetry of that virtual machines are there. That implies that the task which we are seeking to be completed that has to be given to any machine which are having that uniform platform and the system, operating system, and that APIs that has to perform those type of the tasks that it is ready to perform those operation. So in that case, the criteria of a selection of those machines and uh, providing those resources to providing the task to those machines which are having that resources in that the criteria is that how minimal time that is to be used so that the task can be completed. So execution time, it should be minimal. There should be the minimal latency. There should be the minimal jitter. Jitter means that inter delay in that completion of the task, and the assigning the gap between the assigning of the new task between that the task which has already been completed. So having those type of that scenario, we require to assign those type of the tasks. So the controller is having that job scheduler. Likewise, that has been used in the operating system. We have this the multiple number of that job scheduler and their arrival time and the completion times is varied. So in that case, here in this case is that the short-term scheduler, medium-term schedulers, and the long-term scheduler. So those type of the schedulers that has been implied that are being used in order to schedule those type of the tasks in the queues. So in that case, the further constraint pertaining to that the priority may be assigned to those type of tasks which it may be tagged with that priority of the services that can be managed separately. So now pertaining to this, the overall normal scenario is that the jobs are readily available, so ready for the execution. So the machine are there. It is the task of the job scheduler and the controller for this distributed computing environment, which is referred to as a DC controller, that has to manage those type of the tasks. So here, as I said, that the complexity of that algorithm for the load balancing that need to be reducible. Can that be a reducible in the so that it can be computed in the polynomial time or in the NP complete time? If it is a NP hard or the much more complex would be taking much time. So pertaining to that, this statement partition is reducible. This load balancing algorithm is been reducible to the partitioning algorithms where the task of varying in the interval size may be partitioned in such a way that that can be distributed among the machine based on their availability based on their arrival. So here you can see that the very first task is assigned to the virtual machine 1 and the other task is assigned to the B, and then the task A is not yet completed, so the task C is been assigned to the machine 2, and meanwhile that A is completed, the task D is assigned to the machine A, and then when the D is completed or the C is completed, and E and F, if they are arriving at the both interval of the times, in that case, any one of that machine can be allocated, and the other part, once the task get complete, we can assign. So this is an optimized way of scheduling the task so that it is a tightly bound scenario where we are able to simplify this. So pertaining to this, as it is mentioned over here, that it is a more than exponential type of that algorithms where the number of the tasks are more and the availability of the machines are limited. So in that case, this goes 2 raised to the power n, the complexity of that. So pertaining to that, the challenges are there, so that having such type of the scenario with that limited resources available, how in efficient way I can optimize them. So optimization would be required either we do require to use the increase the machine. So in that case, as per that Amdahl's law, the speed up can only be up to that 20%, even if you 95% if you parallelize the operations, and uh, the sequential part which are been there, and the dependency pertaining to that, if it is been there, in that case that would create a bottleneck and that cannot be resolved. But if the number of the code are available in the resources are available, in that case the uh, the disciple or the people of the Amdahl, that the Guftanson, he said that if that number of the core are there, in that case the that the performance of the system would increase linearly. So this is what that has been stated over here, that having those type of the scenario available, and that the core are being number of core are being increased, and the parallelization, if that can be uh, implemented, in that case that load balancing can be done in a much inefficient way by making this efficient partitioning of the task. Likewise, the other type of the mechanism are also there, so which we shall discuss in this lecture. Now, as the one is this list scheduling, where that the current initialized machine which is does not have any load, but that throttle or the threshold of that can be assigned, and the job once that has been arrived or that has been assigned, in that case based on that availability of that machine, that the task can be assigned, and that the period of that can be counted. So the total amount of the times that need to be performed to that task, and that number of the tasks that can be scheduled to the machine. So in that case, that is referred to as that a total amount of the times that is needed to be performed by the machine, and referred to as a load, or that make span, that the completion of the task that can be done by the machine. So based on those type of the task and their scheduling, we can assign those tasks to the multiple number of the machine. And here that the task scheduling algorithms has been there. So in that case, while reducing and providing that task and dividing among the machine would make that reducible complexity. So in that case, the 2n square, 2 raised to the power n algorithms can be reducible to the n log n. And if we are using this priority type of the scheduling with that tightly bound assigning of that task to the machine. So there should not be any gap, and the throttle or the threshold of the machine can be maintained. Pertaining to that, the optimized way that need to be taken into the account, we require to take an average of all those type of the tasks which has been assigned to that multiple number of the machines, and how much that task can be completed. So that will give us that total time span, that is referred to as a optimal make span over here. So in that case, that the length of that or that task should be that the total amount of the times where that machine can handle that. After that, it may get exhaust or it may be too warm to handle those type of the task. In that case, it has to slow down its frequency and increase the time. So in that case, the latency would get increased. So once we know that having those type of that task with that machine, which is evenly being distributed among the multiple number of the machines. So in that case, the fraction of the task, if that has been assigned, likewise, which in that the job scheduling, which has been done in the multiprocessing, multi-programming environment in the by the operating system. Likewise, the similar way that has been done, that the multiple machines can handle those multiple number of the tasks in the distributed cloud environment, and that job scheduler at that controller would assign those type of the task and take that output and return to the user. So likewise, the similar way has been there in that cloud computing environment. So if the number of the machine are being increased, in that case, the two approximation algorithms or three approximation algorithms are those type of that approaches which gives that better optimization techniques where that certain part of that schedules are being fixed or assigned and the rest of them are required to be managed. So here that the blue jobs are ones that are being assigned and the rest of them are based on that which machine can give that better performance, better type of the resources are which are available. And if that task is that machine is free, the based on that priority or that availability of the resources and that space available, the task can be scheduled. So likewise, here it has been mentioned that the task, the bigger task can be assigned to the some machine because someone has to do that. So we cannot ignore that we cannot or that task cannot be assigned to any machine. So like that is also referred to as an starvation type of the problem. So likewise, something like that should never happen. So machine with that small load has to perform those type of the task, which may take a certain amount of the time. So, but being able to compute that, the task can be completed in that stipulated time. So this is what that load balancing in that list scheduling is. So in that case, the challenges are there that if those type of the machines are there where certain type of that guarantee pertaining to that assigning of the job which can be computed by the machine which is readily available, we can assign those type of the tasks. So sometimes we require to fix those type of the tasks to the certain machines and the rest of the tasks that need to be handled dynamically based on that availability of the resources. Likewise, which has been mentioned over here, that the variations of the task which are been there, in that case, the arrival of them would be varying and as soon as the machine get free, the next task is being given to them. So in that case, the challenges are there that a certain task would take a much amount of the times compared to the another one, and that may be because of the multiple constraint that the memory may not be sufficient, the space is exhaustive, and the too much swapping is there, or that the machine is having the extra overhead, which are the other part of the task which is already been done over there. In that case, it has to do that in that time sharing mode, and that would take much time. So pertaining to that, the that greedy approach which requires to look into while assigning such type of the machine to the system is that total span of the time over that number of the machine is required to be computed, and that should be that the time span which is been taken by the one machine for the job that has to be reduced by the total time span that is been required to complete the task. And in that case, the average of that need to be taken. So, and overall, we can state that the burden should not means that for a particular machine, if that is not been there, in that case that would be overburden. So in that case, that the lemma of that is stating that the total amount of that load or that make spam should be reducible to the number of the tasks which are being divided in among the machine, and that should not be that the total amount of the times that can be taken by the single machine. So this is what that lemma states, that the twice of that amount of the times that would be taken by the single machine if that has been assigned, unlike which has been done by the multiple number of the machine. So this is what the desirability is, and we require to use that in that fashion. So let us take an example of this scheduling, that if the m number of the machine are there and m into m minus 1 job length are there, and length of the uniform length of the jobs are there. So in that case, the the total number of the task, let us say that the machines are there and we are assigning them. So in that case, 10 number of the machines are there, and based on this list scheduling, that make spam of that would be 19. So in that case, the 9 into 10, all these are the 9 into 10 plus the 10, the 10th machine, which is taking only that one part. So in that case, the total time span of that scheduling would be that 10 plus 9, because the rest of that would be available, so but that are there. So that 9 of them would be there, and the 10 the 10 of that machines which are exhaustively being used. So in that case, that would be there. So the total scheduling time span would be 19, and this can be computed like here. I give you this example if it has been visible. Okay, so we require to divide this time span with the number of the machine, and take that values, and in this likewise this the 90 number of the tasks which are been there with divided by this, so that gives us this value 9, and the rest of this task that 10 machine are there, and and that the longest job which has been assigned to that machine, comprising that entire span of the times. Likewise here in this 90, so that is taking that too much number of the times, so pertaining to this the total time that has been taking place. So one if you take into the account of this 1 to 8, 1, 11, 21, 31, 41, 51, 61, 71, 81, so all these are the total 9 stages is, and the 10th would be that the entire time span that would be taken by a single machine. So in that case, that is giving a longer time span to complete that entire task. So likewise, if this task pertaining to this, which is referred to as a blue line, is that 91, if I assign to all these 10 number of the machines in that equivalent distributed way, in that case, the time span would be reducible to that 11. So this is what is that advantage of the load balancing is, that if the task pertaining to that can be shared among the machines, in that case the complexity of that would be reducible, and the operation can be completed easily. And this is what that the flexibility is available in that cloud-based systems, where the load balancing can be done by assigning those multiple tasks which are independent and ready for the executions, and that can be shared among the multiple machine, and we can execute those type of the tasks. So here is that load balancing algorithms based on that the number of the jobs which are arriving at the different time span, and the criteria of assigning the task that can be varying, and the longest processing time that which one is taking the task has to be assigned to them, so that that can be executed while the other can compute the that can be initiated first, and the rest of the machine can compute the other task, and that would be the better time. So likewise, which has been mentioned over here, that one machine 91A or the 10th machine is completing that biggest task, and the other tasks which are having that the equal time spans, so that are being divided among the multiple number of the machine. So this is what has been stated over here, that that smallest job that can be divided among that can be divided and assigned to the multiple machine, but that job which is the longest one, that has to be given to the single machine who has to handle all the tasks. So meanwhile, that the total amount of the time or span that can be reducible. So in that case, uh, this likewise, this I have stated that while making such type of the scenario available, we can say that the dividing of this task would give us that near to that approximations up to that that the 75, more than 75% of the task that can be scheduled, and it is that a task can be reducible with that two-third of that total amount of the times that would take place. So likewise, this is a beauty and the advantage of assigning wisely such type of the task over that number of the virtual machine which are being assigned. So certain challenges are there, that whether such type of that analysis would give that accurate solution pertaining to that, the answer is no, because that would be varying, and it depends on that the type of the task and the machine which are available, and the current task which are been there. So in that case, the uh, difference between that of 3 by 2 and the 4 by 3 approximation gives that certain analysis that the better approximation would be for the larger set and the machine, which will give us that better task scheduling compared to that limited resource with the multiple number of the tasks. So this is what has been stated over here as a 3 by 2 and the 4 by 3 analysis, whether that is rightly bounded or not. So pertaining to that, certain type of the solutions based on that dependency that can also be discussed over here. So if that dependency are there, in that case, how that need to be handled. So in that case, we require to identify those type of that graphs with that directed acyclic graph, and in that case, the assigning of the task based on that availability or the probability of availability of the resources and the probability of arriving that particular task, and the completion or duration of that completion of the task, that would depend that whether that task can be assigned to that particular machine. So if this type of the scheduling is there, and in that case we require to go for the total scenario where probability of arriving with the task with that computation times and the length of that period of, based on that the task would be completed, and how much that time period or the span would be, based on that the amortized cost can be assigned. And if those type of the challenges are there, in that case, how that the system would manage them. So in that case, that would depend on that availability of the machine. Sometimes you may have observed that that machine is not operating, or that we have to wait for them so to get activate, or that application we require to seek the permissions to activate that application. Based on that, the task can be completed. So in that case, the 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 processing charges, availability of the resource charges based on that timing constraint, and the job scheduling pertaining to that task that need to be assigned to that particular machine, that would make or that cost, and that has to be paid by the person who wants to use them. So in that case, we require to think wisely while assigning certain type of the task based on such type of the system. So in that case, the task can be scheduled and the batches of that operations that can be assigned. So as you can see over here that the entire workflow for the variations of that task which can be assigned. So there are the two terms which comes in this picture. One based on this quality of the services. So quality of services implies that there are the two things. One is that assigning of this bandwidth, that is the guaranteed throughput, and another one is the best effort technique. So best effort implies that whatever that resources that are available, it has to apply them, use them exhaustively to give that result. Whereas in that the guaranteed throughput, whatever that bandwidth which has been assigned, whatever that resources that has been assigned, we require to get this assurance that having those type of the resources with that availability of the bandwidth and the constraint, other constraint, my result should be available, and that need to be completed in that stipulated time. And that is what has been mentioned over here, that a certain task may be based on that best effort technique. So two things I have stated: guaranteed throughput and best effort. Guaranteed throughput implies that it is has to be where with that availability of the bandwidth, availability of the resources, the minimum bandwidth which I require, maximum that the the resources that clearly that need to be mentioned, that these are to be used. The checkpoints pertaining to that are required to be maintained, that the deadlock constraint and the budget should not override, and the task should be completed in that stipulated time. Whereas in that best effort techniques, which are mostly in the heuristic nature, the variations in the times would be there, and the availability of the machines may be there, and that may change. In that case, we can apply the different type of the scheduling algorithms. We can apply the redundancies of those type of the resources, and a certain task can be done immediately. Certain task may not be able to get complete. In that case, we'll have to go for the long or wait for the longer period of the time. Some of that based on this best effort techniques are greedy in nature, so where that randomized approach are required, or certain type of that fast computations based on that simulated annealing and the genetic algorithms that need to be there. So pertaining to that, I would state that this simulated annealing is the fast exponentially reducing that number of the input while making that outcome, and repeat that operation for the multiple number of the times to mitigate the error. So likewise, the same thing is been done in that the uh, the best machines that need to be taken with that best amount of the resources and bandwidth, and using that the task need to be distributed so that the outcome would be uh, taken in the fastest way. So simulated annealing is the commonly being used in order to reduce the time computation time of the machine. So the thousand, and if the 1 lakh inputs are there or the jobs are there, and 10 machines are there, so in that case the random those type of the tasks is to be given to that machine, and that they will have to compute that. So if that the performance of that machine is required to be estimated, that how much that benchmark would be, in that case the random data, random tasks that need to be taken and that need to be assigned, and that has to be computed while reducing those that input, and from that thousands or the 10,000 to that uh, minimal one that has to be taken, and average of that if it has been taken, in that case we get that better optimal solution, and based on that the task can be assigned. So likewise a similar type of that operations we do use for the machine learning techniques, where the fast way of getting the result with that is that simulated annealing environment, which will perform by taking that random values or the random data and operate upon them, in order to compute the task in the fast and efficient way. So just hold on. Now this heterogeneous effort, which is the best effort type of the technique, as I said that it is heuristic. Heuristic implies that the output may be not same, but that would be vary based on that availability of the input. So in that case, one machine, which if the 10 task is given to the 10 number of the machines, so in that case, one machine may compute the task in a certain scheduled time interval would be not the same if the similar type is assigned in the different time interval. So in that case, the assigning of the task interval between them, the cost pertaining to them would be varying, and that is a chargeable task where we do require to look for that amortized cost analysis pertaining to that how and best and efficient way we can assign them. So pertaining to that, the challenges are there that certain task can be assigned with that fixed interval, that even though that a task has been completed previously, the next scheduling time would be assigned, and only on that all those machines which are freely available, so they will have to give those type of tasks and they will have to complete them. So in that case, the real-time scheduling can be assigned to complete those type of the tasks. So certain threshold and that constraint based type of the task assigning is a critical one where that we need to look into, because there are the certain type of the dependencies associated with that once that task which has been completed, only in that case the other part of that can be taken into the account, because the data which is the outcome of the previous task would be used by the another one. So in that case, the direct acyclic graph is commonly being used, where that the the dependencies are there, and the execution of the task would be done based on those dependency and availability of the resources. So generalized term pertaining to this directed acyclic graph is that it is a directed graph with the vertices and edges, and the vertices are the tasks that need to be completed. So task may be having certain period of the time assigned, and that would be varying, and the edges are there that having those type of the task which is to be completed, the output of that would be passed to the another one, and based on that or the decision that has been taken, the other task would be initiated. So in that case, there is a single direction type of the task. Okay, so one entry and one exit, and the size of that, what type of the task that need to be operated upon that particular machine or the node. In that case, that would be varying, and the data either that may be fixed or that may be varying, and it is the responsibility of the controller to assign those type of the task based on that availability of the data to the machine. Okay, so in that case, the uh, like this MMQing technique, where that the type of the machine operating condition would be varying. So take an example of any type of that banking services or that post office services or any shopping mall where the multiple counters are there. Some of them where here I am referring to this as a part of this queue heterogeneous machine, that one may be doing the task efficiently, other may be a slightly lethargic or may be sick and may be doing that task with that delay. So in that case, a similar type of the scenario would be there, that the add-on or the additional task that are already been assigned, and in that time scheduling the machine may be performing that task. So in that case, the period of stimulated period of the time. So based on that, that a task need to be completed, that would be vary. So in that case, the total execution time need to be minimal based on that availability of the machine and the task that has to be performed over those machine. So the total amount of the times pertaining to that is the one task that has been given and the last task that has been completed. So total that time is referred to as a latency of that task assignment to that very machine. How many number of the tasks which have been given, and uh, with that interval, with that all those multiple constraints that the delay in the task assignment, the inter-task differences, and the total time spent that has been computed with that task that could be varying. So in that case, the first task which is been given and the last task which has been completed. So total time spent between them is referred to as a latency pertaining to that very machine. So in that case, that the parallelizations and execution of the multiple tasks to the multiple machines would give us that a better flexibility and availability of the multiple path and which is referred to as a bandwidth to compute the task in a parallelized way, parallelized and efficient way. So likewise, here is an example that there are the 10 number of the tasks which are arriving at the different interval, and in that case the tasks need to be performed based on that the task which is currently being there and the task which has to be computed. So likewise, you can see over here that the three processors are there. So with that different time intervals, the task which are being assigned. So in that case, the variations of this time intervals based on that they are arriving or they are taking the other task which is available, so that has to be given to them. So here you can see that the process the process 3 which initiated this first task. Okay, so meanwhile the other tasks which are arriving at the different interval. So the next task is arriving at the 11th interval. So that has to be given to the another process. Well, and the once the other part which are been there like the N4, you know, so in that case. Uh, okay, so that can be given to the because the P1 is not free, so that can be given to the P2, and the P1 of the process 1 or the other task that like this N2 is there, which is running at the interval of the 18. So in that case, that will restart, and it is also having that certain time period that it has to be computed in that period of the time. So based on that availability and that amount of the times which can be there, in that case, the tightly scheduling of this is required to be done. So most an efficient way pertaining to this is there. Based on that availability of the time, we'll have to divide that and sort this task in their stipulated time of the period in which that can be completed. So in that case, the resource, if it has been available, so the task can be assigned, and the other one which is readily available, ready for the execution, and the resource is available, the next task can be given. So in that case, all those tasks based on their availability that has to be sorted in that order and should be provided to the resources. In that we will have to make that optimized way of the solution for assigning that task that can be computed in the minimal time. So in that case, the average waiting time, so if it requires to compute, that would be that the total amount of the time based on that the task which has been computed over the machine. So that would be there. So we'll have to take an average of them with that total processing time. Okay, another part, because it has to be referred to as a part of that latency and the execution cycle or the number of the tasks that are executed. So the latency implies that the tasks which are being scheduled and how much amount of the times that is taking place. So in that case, the execution time plays a very much important role. So we have the three simplified term. One is that the speed upon which that machine is operating. So number of the clock cycles required to complete one task, or and another is that how much the slack time is there, that is an inter process gap, which has been there. One task is completed, the another task to be which is to be assigned, it may have to wait for that because of the certain delay. So the total amount of the times that need to be computed. So in that case, and that latency pertaining to that the data which has been transmitted from the by the controller from one machine to the another machine. So in that case, the total estimated, this bar indicate that estimated time which has to be computed, which would be that the total computed average time that referred to as the total length of that task, the latency in the simplified terms, and the data which has been transmitted with that available bandwidth. So this is what that in the way we require to compute or estimate the total cost pertaining to them. So having this, the the total the in that directed graph there are the multiple tasks which are having that dependency. In that case, associated with that availability and the performance based on that, the ranking of those type of the tasks based on that node can be assigned, and the task can be computed in that way. So if that level of the computations is more, and so in that case, the ranking of that would be more, because you require to make multiple number of the times from that very machine. So in that case, that would take much more time. So in that case, the priority of that would be assigned, that to whom so that a task should be given, or whether that need to be switched to the another one. So based on that, the complete critical path and the availability of the resources. So I am ready for the task. I am having the task which is ready for the execution, but I am having the three different type of the machine. One is slightly slow, which is already having certain tasks. Another is completely free, and some other one is that is also having the task, but which is faster and able to complete that task in a better and efficient way. So in that case, I will have to look into that. This type of that machine would be better for me. It is the task of the controller. Based on that, it has to assign the ranking and assign the task to those type of the systems, so that the task can be completed in the efficient time, or the minimal time is spent. So in estimation pertaining to that is a very important part, that how much time so that is taking place, and that would base on that availability of the machine, the number of the job which can be assigned. So it is the criteria that the maximum job the machine should be able to compute if it has been assigned. Pertaining to that, the recurring cost of certain type of that frequency of the data which has to be taken from the other sources, and the computation time or overheading part that has to be computed. So the overall estimate time, so that has to be computed. So likewise, I stated that the very first task which has been assigned is the very last task which is completed, the total amount of the times should be counted in order to complete that task. So in that case, the task or that assigning and scheduling that task would be varying. So likewise, that the the critical path pertaining to that, the availability of the resources and the scheduling of them, based on that, that can be managed. Likewise, which has been stated over here, that having that dependency of this task available, the other machine would have to do that on that directional, based on that directional graph, and they will have to follow that critical path until that data, if it is not been available, like that, the N1 is task once it has been completed from the P2 process. So the next task, which is dependent on this N1 values, is N3 and N4. N4 is first initiated by the machine P3, and its dependency is with the N9. So in that case, the N9 is until and unless this N4 task is not completed, this N9 cannot be assigned. So in that case, it has to wait. So even though that the other slot is available with that machine, but that the job is not yet been completed, we cannot assign the task. So these are the challenges that need to be followed. So this is a critical path assignment, and in that the two things are being used. One is this as soon as possible and as last as possible. Likewise, that type of the techniques which are being mentioned over here, based on that, the scheduling of the task has to be done in that way, so that the minimum select time can be there, and the maximum, minimum, or the maximum uh, that the execution of the task must be there with that minimal execution time. So I require to have the fast execution, implying that minimal execution time. I do require to have this minimal select time. Whatever that is space which or the machine which is available, immediately that task is to be there, assign, which we have to assign. So there should not be any waiting time, and that the total latency pertaining to that the job which are being assigned and the task that has been completed. So that has to be minimal one. So this is what that the challenges are there. So another important aspect of this cloud computing is that uh, the dynamic type of the scheduling. So the scenario, the dynamic implies that the the task arrival of that task is varying, the size and the computation time is varying, the resources available with us is different, and that would be varying. And in such type of the scenario, how our system would be able to manage the system. Pertaining to this, so the challenges are there that the application which I want to execute, this application may require exhaustive resources. This application may require large data size. This application may require certain type of that computations which may not be available with that virtual machine, like that gaming applications where that input from the multiple resources and the constraint base, and that data transformation in that case, which has to be performed. In that case, the GPU need to be there. If that virtual machine is not having that type of that resource available, in that case, if that task is assigned, in that case, that machine would be failed in order to complete that. So what would happen if I am assigning the task to that machine, which I later know that that was the one of the worst type of that machines which could perform those type of the tasks, because it does not have that minimal resource requirement pertaining to that the application requires, and the task cannot be complete. So that type of the problems are the common scenario nowadays while assigning such type of the task over the machine. So my challenges are there that while assigning those type of the task in a dynamic way, my application should be assigned to those type of the machine which are sufficient enough to execute the task, and having that efficient sufficient resource and the computation capability to execute those type of the tasks. Okay, so if that has been there, so the burden would come to that person that if you want to use those type of the resources, you have to pay that. Okay, like that real-time gaming services nowadays. So there are the certain deadlines that whatever that command which you are giving through your hand or gesture, that has to be executed in that real time, so that the decision has to be reflected, and uh, that should be shown among all. So the faster computation is required. So whether that constraint can be managed and in what way? So in that case, there comes to the cost. The cost is very high. Like nowadays that the PS5 or PS6 type of the systems are there, where that 256 and 512 GPU or thousands of the GPUs are there, and that are interconnected, and the multiple users who run that gaming program. In that case, pertaining to that, it requires the highest bandwidth, the 5 gig type of that system, and all those fast speed of the computation, and those type of the devices which can connect together and perform those type of the computational power, and schedule all those multiple different type of the tasks which would arise based on those type of the conditions which are arising at the next level. So pertaining to that, the constraint based scheduling are there. So constraint implies that, as I said, that the timing constraint, cost constraint, the amount of the times which is been required, and at what level we requires to, we expect that it has to complete that task, and in other way that the overall performance of the system should be such that it has to complete the task in the stipulated time. So in that case, the the most and efficient way the task need to be completed is without making the extra burden to the system or the person who is using them. So that is referred to as a loss gain approach. So the loss of the weight of that scheduling with that budget constraint is that the task which is available, which is currently going to be assigned with the task which has been computed, and the cost pertaining to the the task which was earlier been done, and the cost of that new task which is to be there. So in that case, this lot waste ratio has to be managed with these equations that are T new minus T odd upon the cost of the old one minus the cost of the new one. Okay, so these are those type of the cost in terms of that time span, and that is taking place by the machine. And the budgetary estimation pertaining to that is required to be managed. Okay, so the easiest way is that I do requires to look for that the nearest machine which is having all resource available, so and compute that times without having any overhead. And if that has been there, in that case, my task would be completed in an efficient way. And that is what the exploration is. Likewise, I will give this example of that broker architecture which has been used in the CORBA, the common request broker architecture, which has been used in the distributed computing environment, where that the broker are the intermediate machines which look for those type of the service machines who has to handle the task of the end user, that which machine is the nearest one, which machine is not overburdened, to whom that is to be provided, what is the time span. Based on that, the stamping of that timing can be done without and that has to be that record of that has to be updated in that accordance. So in that geographically distant apart systems where the the machine are working in a different time zone, in that case the Lamport clock synchronizations are required to be made, or the other that the matrix based type of that time streaming is required in order to handle those type of that task assignment and scheduling of the task. So in that case, the challenges are there with that machines who are being operated at the distributed computing environment with that multiple virtual machine referred to as a cloud part, where we need not require us to bother about where that is been located and what time it is. And we just require us to assign the task and that has to be completed. So the clock of the current time at the place where I am working, I need not to be consider the clock of the and the time and the space and that place where that machine is located, I need not require to bother about that. And the task has to be completed with that machine which has been assigned, and that has to be delivered to me in such a way that I assume that this has been done with that my specific time and intervals based on that the task has been assigned. So pertaining to that, the fast scheduling is required and the optimized way of the solutions that need to be there. So concern thing is that you requires to do that task in a priority basis, fast scheduling mechanism, best effort technique, and that need to be minimal one. Okay, so in that case, uh, HEFT, as I said, that you'll have to consider this as a best effort type of the technique. Most of the times, we require that whatever the task which I want to make, that has to be completed irrespective of whatever that condition is. And this type of the common scenario is where the people require the task distribution that has to be handled by the controller, and other are least bother, or the user has to be least bother about that. Whereas the time, if it is been scheduled and the specific guarantee pertaining to that the quality of the services that need to be assigned, in that case we'll have to go for the guaranteed throughput. So pertaining to that, the challenges are there that having this directed cyclic graphs with that dynamic approach of assigning the task to the multiple machine, and all these machines, the dependency are required to be estimated, and this availability and the usage of the machine would be based on that the probability and availability of that resources. So assigning of the task based on that the higher probability and the better computation or the faster computation time would lead us to give that the execution of the task with the minimal period of the time, and that is what the desirability is. So the sparing spare time, that how much that time is taking place, so the select time, as I had mentioned, that it is the interval between that the tasks which are being assigned, and that has to be computed. So in that case, the assigning of this task is based on that priority and scheduling, likewise, which has been mentioned over here. And in this, the dependency of this task can also be managed in such a way that the resource utilizations and the minimum slack times that can be there. This type of the challenges are there in every multi-core type of the architecture which we are currently using. This type of the things has always been there in that operating systems to handle such type of the tasks which need to be managed by the system. This type of the scheduling with that dependencies are being handled by the system, and in that the task scheduling which is been performed, in that case the scheduler or the compiler, if that the same type of the task which has been assigned that need to be computed by the compiler, it has to rearrange that at the at the that syntactical analysis stage, and that task would be assigned in that order, and based on that the task would be computed by the system. So likewise, having the known information pertaining to the task, pertaining to its foundations and the limitations and the dependencies, that rearrangement of the task has to be done in such a way that the minimal select time should be there, maximum execution time of that, availability of the space or the sparing of the time of the machine should be there, and the task can be completed. So pertaining to the I will make a break. कितना time बाकी है आकाश? Half an hour. Okay, so I will make it the 5 minute break, and then I will stop. है ना? 5 minute break. थोड़ा सा मेरा गला तो गया है. If you have any question in between, please put Agam, am I audible and visible? Okay, so welcome again. And now that a practical scenario pertaining to that the task which or that work which we have done in our institute and the research work that has been implemented. This task I shall discuss pertaining to that the simulating environment would be discussed in the evening. So this would be a one-to-one uh, discussion and thus live demonstration and the scenario where such type of the uh, load balancing algorithms and that cloud environment we discuss over here. So very first thing is that this load balancing is a challenging one. That a number of the machine are there, constraint based that the execution time should be minimal, the optimized way should be there, the latency should be minimal, the the task execution should be fast, and the total execution cycle should be minimal. So pertaining to that, the load which are been to be assigned among the multiple number of the machine in the cloud-based environment, how and better way I can optimize that. So pertaining to that, two, three algorithms, or in fact, the five algorithms that I shall discuss over here, with that emphasis on this fuzzy randomized approach, which is giving us the best and optimal way compared to that other one that are existing and that are being included in order to look into the best way of making the load balancing in the cloud-based environment. So, as I said, that the concerning thing is that what type of the scenario which I am using and what type of the resources do I require, how much the times that need to be used, how much money do I possess to give that to compute the task, and what type of the application or the services infrastructure, whatever that that are there. So I do have this multiple platform, multiple type of the variety of the resources, variety of the applications, and the cost pertaining to that, and the type of that delivery models that has to be used. So main multiple companies, they have their own data centers, data warehouses who are providing such type of the services. So this is a multi-model type of the scenarios where I do require to put all these different type of the constraints and look into that whether this type of the scenario, if it has been existing and that requires to be used for my application, in that case, how that can be implemented in the most efficient uh, and balanced way. So pertaining to this, if I am running a data center, if I do have my own cloud system, likewise in our institute, and if such type of the request is arriving that I do require to have a cluster of the computer system with that 100 number of the core, 50 GB hard disk, 50 GB of the memory, and that has to run on this specific Linux operating system or the Ubuntu operating systems, and it has to compute my simulating environment, which requires an additional library which has to be taken into the account, and that has to acquire this much of the space. So if the something like that is being done, so in that case, either one machine or the multiple virtualized machine can perform that. But if I require to take that in a global scenario where I need not require to use them and without my knowledge, in that case, it is the task of that the data center and the controller over there. So to distribute this task among the available of the virtual machines so that the task can be completed. So the balancing of this task is a key concern while managing the cloud computing environment. So here, the fuzzy inferences based rule, which is also referred to as a machine learning techniques, if it has been there based on that, the flexible type of the scenario where that the threshold can be assigned and used based on that, the decision can be taken whether that machine should be taken into the account for assigning the task or not. So those type of the things are there. So in this case, the challenges are there that the demand is there and that may arise at any instant of the times, and the data center controller has to take, and the load balancer who operates along in that data center who has to manage this task, where that varieties of the multiple number of the virtual machines at the different locations where that application can run, the task can be assigned among them in a best and efficient way. So this is the challenging task with those type of the multiple constraints that I am repeatedly stating, that the task has to be completed with the minimal time so that the maximum time it has to be available for the other task, and that has to be completed in the with that minimal cost. So the cost implies that the amount of the times that you have used that machine, amount of the computation times that it has performed, the number of the resources that it has used, and the data which has been exchanged, the size of the data, quantity of the data, and the computation that was performed based on that data. So in that case, the recurring cost of that and the amortized cost pertaining to that, the running of the task that would be that has to be minimal, and that should not be any loss to the service provider. So in that case, the challenges are there in the what and efficient way I can assign the task. So we have the varieties of the ways where that can be managed. One is this static load balancing, where that the fixed machines are there. There are the master node and the certain type of the client node. Client nodes, the master node assign those type of the tasks to the client nodes, and the client node perform those type of tasks and return them. Whereas in the dynamic load balancing, which is the most common in nature nowadays, where the task has been distributed among the ROM at the runtime based on that the availability of the resources and the machine uh, which are there, and the task has been distributed, and with that strategic way, in such a way that the cost of that would be minimal. So in that case, the what would be the criteria of load balancing? So load balancing implies that the machine upon which that the task need to be performed, whether that machine is having the sufficient number of the resources. Like I'll give this example of this machine. It does not have any GPU. It does not. It is having this quad core architecture, 16 GB of the memory, 1 terabyte for the hard disk space, and the 8 MB of the cache memory. So in that case, the assigning of all this memory, space, time, and the speed of operations, based on that, I can claim that this is the resources which is available to compute this task. If I connect this to the master node as a part of that node, which can take the task from the master node and perform that computation and return back, in that case, I would get some sort of that amount of the money that has to be shared by them. Likewise, which has been done in that the blockchain scenario, where the miners use to their machine or connect their machine to compute that authenticity of that the operation that operation which has been performed, and the 51% of that miner, if they gives this acknowledgement and agree upon that, in that case the decision has to be taken by them, that blockchain machine. So challenges are there that I may be having a limited resource. Do I require to increase that resources? And if that varieties or the heterogeneity of the architecture is there, in that case, how an efficient way I can handle that. So in that case, the challenges are there that the task should be completed in the stipulated time. The throughput must be high, latency should be less, which is also referred to as a delay. Response time, I am referring that as a latency, and these are those type of the constraint. So in that case, we have a variations of this load balancing algorithm, static and dynamic. In that static, three different type of that is algorithms. The classical algorithms are there. One is the round robin algorithms where the task has been assigned in the round robin method. Another is the min-min algorithms where the minimal when load balancing is required to be made in such a way that the the minimum response times is to be assigned to that machine which is having that minimal load, and that is what that objective is. And another is that the max min where the machine is having the maximum uh, the faster execution times and the that implies that minimal response times and execution time is very fast. So that is that maximum uh, execution time or the maximum completion time and the minimal response time. The minimum one means that it is having that minimum completion time and the minimum response time. So variations of that are there that these are the fixed machines which will take this much of the time. So pertaining to that, the what does it states that my speed of the system is limited, my resources are fixed, I have the fixed amount of the memory and the task which would be computed. So there is no as such dependency or the some task which has already been there, and that would be that is associated with that the burden of that delay is there and that is fixed. Like unlike that in the dynamic approach, we require to actively monitor all those type of the machines where the allocation can be done based on that availability, its performance, its all those type of the minimal execution time, maximum number of the tasks that can be computed. That implies that it is having that plenty of the resources, and that would be given that preference to give that a chances so that the task can be computed in the faster way. And another is that the certain type of that threshold that can be assigned to that machine that this machine can handle 10 number of the tasks simultaneously. Some other machine can handle the 50 number of the task. Some other machine can handle along with this task, but some other additional task of the fast math computing or that computer's vision or the image processing task which cannot be performed by the other because it is having the GPU based type of the system. So in that case, I can assign those type of the task with that certain threshold level so that at least it has to perform those type of the task if it has been assigned in that case that can be computed. So the boundary pertaining to that the total task which are been there that the from the bottom to the top which may be varying in that case the the uh, box plot which gives this a better representation of that where we can define this the lower threshold and the upper threshold and in between that while if the task has been assigned the average and the mean of that can be computed. So all these can be visualized using the box plot and that gives us the better picturization and the evaluation of the algorithms if it has been assigned to the system based on that the threshold based algorithm referred to as a throttled algorithm. So in that the machines which are being used, so we require to create the map Associated with that, the tasks need to be allocated. Associated with that, the load balancer which work with that, the controller has to look into the task, how much times it would take, which machine would be the best suitable, and in what fashion that need to be assigned, and what approach we are applying, whether that is an static or dynamic. It is the option which has been available at the controller level, and that the machine would be allocated based on that. How much amount, how much that quality of the services and the resources requirement that is expected. So in that case, uh, the number of the machines which can perform the task, and some other machines which may be there, which are already working in that. So we'll have to categorize them also in that, whether which machines are available and which machines are currently busy. So while performing or evaluating such type of that load balancing, concerning things are that the resource on that machine, virtual machine, which are using the how much memory, how much bandwidth, how much the disk space, and how much the uh, additional resources available, whether it is having the GPU, whether it is having the booth multiplier, valence multiplier, how many number of the adders are there, how many number of the tools complement circuitry, and the bitwise operations that can be performed, or the bit shuffle is there. And these are the least type of that scenario which is expected to be there. Sometimes in order to make the faster computation, sometimes that the graphical instructions like the MMX type of the instructions that has to be there to perform such type of the computational work which are required for the image processing. So 54 instructions are already been there in every core in the CISC-based system, who has to perform such type of that fast image processing on that live streaming of the data or the video imaging part. So the challenges are there, that varieties of the ways where that application need to be there, and it has to perform those type of the tasks. So can we be fixed, or there can be a variety of variations that can be applied. So the fuzzy logic implies that I may be having a lower limit and upper limit, which would give me this indication, so that having this type of that limitations, that if I know that this machine can handle the 10 amount of the task, but currently I have already assigned the 5 number of the task, whether it can handle the further for the 5 number of task, or should I assign only a slightly part of them based on that the already task it is performing. So this is the variations on that the flexibility should be available, and if it is been there, in that case the multiple stuff the scenario, if that does exist, so in that case the fuzzy inferences or the rule based technique, if it has been applied, in that case that would give us the better optimized way of making the solution for the optimized way of load balancing. So unlike that Boolean logic where that the specific key values are to be assigned, in the fuzzy inferences way, the variations is there where we can assign that the values in that different intervals, and that can be the part of that decision making criteria to decide that whether the machine is too exhaustive, machine is working moderately, or machine may not be working at all. So in that case, the task can be assigned likewise to those type of the machine. And that is what that advantage of fuzzy inferences is. Inferences means that intelligence, that a machine is intelligence in those type of that order which has been defined as a part of that rule tables, and those type of the rules are explicit pertaining to that, making that a decision, that having those type of the machine, having those type of the scenario, what would be the decision that need to be taken? So in that case, the fuzzy file which takes those type of the input, the data set, and assign those or explore that with that fuzzy inferences rules, and make that decision that what type of that machine should be assigned to whom, and that is what that the task is being assigned based on those the output that this would be the best machine pertaining to those type of the rules which are being there. That let us take an example. One machine is having fully memory utilized, or 80% memory utilized, 80% of the computation power, and 80% of the disk space. Another machine is, it is having the 20% of the space you use, and 20% of the CPU utilization, and the 20% of the memory utilization. So in that case, I would give the preference to this, that this is the more better machines compared to that of the previous one, because that would take much time, because that is already exhaustive in nature. So in that case, the decision that is referred to as a, that based on that rule base, the decision has to be taken, and using that the task has to be assigned. Now this assigning of the task would be varying based on that the dynamic approach that we have already discussed earlier. So in this, the certain type of that membership functions are there which requires that whether that decision has to be taken or not. And in that, the criteria that has to be followed based on this rule. So the constraint, what are that has to be based on those type of the constraint. So constraint which I am following, the decision has to be taken in that accordance. My constraint pertaining to the machine would be कितना memory है, कितना कंप्यूटेशन पावर है, कितना डिस्क स्पेस है, कितनी बैंडविड्थ है, ओके, कितना हार्ड डिस्क का स्पेस है, कितना मेमोरी का स्पेस है, कितनी कैश मेमोरी है? तो उसमें फिर मैं इन सब के मिला करके, और उसमें भी मैं अदर मल्टीपल अलग अलग स्टेज पे मैं उसमें मीडियम, स्मॉल, मीडियम, जो है स्लाइटली मोर मीडियम, है ना, एवरेज, लार्ज, वेरी लार्ज एंड ह्यूज, 5 6 7 इस तरीके के मैं उसमें वो कंस्ट्रेंट, वो जो है ना, वो ये रूल लगाता हूँ, और बेस्ड ऑन दैट आई विल हैव टू असाइन दोस टाइप ऑफ द रूल कि ये ह्यूज है, इसमें डिस्क स्पेस अवेलेबल है, इसकी मेमोरी भी अवेलेबल है, इतनी अवेलेबल है, इसमें डिस्क स्पेस इतना यूज में आएगा, तो वो बेस्ड ऑन दैट ये वाली मशीन इसके लिए सबसे बेहतर है. So I will repeat that in English, based on different type of that constraint pertaining to that the rule has to be assigned, and rule has to be assigned, and based on that the decision has to be taken. And these are those referred to as a membership function of the fuzzy set. So like the as I said that the processing element कितने हैं, storage कितना है, RAM कितनी है, bandwidth कितनी है, some initial specifications that we may assign, and how much that can be allocated. So in that case, the cloud sim we applied this optimizer fuzzy load balancing techniques over this type of the scenario, where we have considered that the machine are which are being considered having this type of the specifications, and pertaining to that the rules are to be assigned. So if I say that the memory usage is based on this and the threshold which I am assigning, that the very low would be that if the value of this x is less than the 7200, okay, KB or MB, and the memory usage would be that how much that memory. So in that case, the maximum with that minimal, the in between that is would be referred as a low, and the medium would be that of 1440 to the 21660, and the high would be between this 21660 to the 28880, and likewise the very high is that 28800 to the 236000. So this variations of or the gap of that availability or the usage of the memory, if it has been there, based on that I will have to make the decision. So in that, the usage of that would not be allowed to the machine which requires the larger space of the memory. I cannot assign the machine which is having the low space. So in that case, the lower two limitations of the very low, the low and the small would not be useful for the machine where I require that services which requires the 2800 amount of that unit of that memory space. So I think that you would be able to understand that this is the usage of the memory requirement. uh, Likewise, the other bandwidth are there that we can assign the similar type of that range using which that decision has to be taken. So, if that task which requires the less memory space, less amount of the computation time, less amount of the bandwidth, in that case, the lower space of that, if it has been there, the machine can be assigned. Okay, and similar to that, the disk space is there. So with these three different type of the example, with these three different variations, the combinations, if we combine them together, would be around 25, 27, 9, 333. Am I right? So there would be the multiple number of such type of that constraint if that is to be used. So the generalized way of representing this membership functions with that constraint base would give this parameters so that what type of that the usage of the memory and the bandwidth would be if it has been used. So in that case, in order to make such type of that simulation environment, we require to create the virtual machines and the request of the task that need to be allocated, and the task allocator or the controller or that virtual machine task allocator would assign those type of the machine based on those type of the rule based constraint. So all these variables which are being used as a part of this fuzzy inferences that has to be taken into the account, and the status of the machine, whether that is busy, very busy, moderate available, highly available, the best suitable machine would be assigned. So in that case, the randomize randomize implies that randomly that type of that machine has to be chosen among those available with those type of the fuzzy inferences rules, and that all those tasks which has been assigned to them, and that has to be queued in, and if the machine is busy, in that case that a separate queue pertaining to that has to be created. So like that the user gives a certain request pertaining to that the controller or that a data center controller assigned has to follow this fuzzy rule based load balancing technique. In that case, it has to explore that whether that machine is available or busy. So in that case, first that a task has to be queued in, and it has to check the availability. If the availability is not there, in that case, it or that if that availability is there, in that case, it will assign the task and put them in the busy state. The other tasks which are there, if it has been there, and the DC controller would see that all these tasks, if that are exhausted, is not available. In that case, it has to wait for that and seek that which machine would be freely available and the task can be given. So likewise, that we assign that the two different type of the threshold pertaining to that two different type of the stack where that or the queuing of the task and the virtual machine, and based on that the decision has to be taken that which machine would be freely available, and if that has been there, in that case that would come from the busy state to the available state, and the task will be scheduled to them, and that will be in the ready state. So the changes in that assignment of that task would be there, that which one is having that minimal task which can be offered to the machine, and the order of that can be maintained in the virtual machine. So let us take that some of the all the certain tasks which is already been assigned to the machine, and these machines some of them are working with the two tasks, some is working with the three tasks, and some are not available, some are available with that task which is already been assigned, but that can manage that another task. In that case, the task can be assigned to that machine. So likewise, this fuzzy rule based and assignment of the task based on that threshold values and their constraint that can be assigned. And we'll have to use those type of the or take those requests, put that in the request queue. Now those type of the queues which complete this task that has to be dequeued. So in that case, those tasks which are have been completed, the space of that need to be cleared. So in that case, the dequeuing of that has been required to clear their task from that is that queue once that gets completed. So this is mentioned over here as a deallocation of the process after completion of the task. That is referred to as a dequeuing. Now, sometimes the challenges are there that we is there any further way of modifying that task? So in that case, the if this fuzzy threshold based or rule based efficiency is to be estimated compared to the existing one where the round robin min and max min are to be compared with. So in that case, you can see that the throttle based round robin base and the fuzzy inferences base, as we increase that number of the cloudlets, the computation time or the CPU utilization time is very less compared to that the round robin and threshold. Reason because of this that it is giving this 9% base better utilization, that we are using of selecting those type of the machines based on their maximum availability and its usage, unlike which is been done which is not been done in the other round robin and throttle based or the threshold based algorithm. Still, you can see that over here that the fuzzy inferences would also require that the lower and upper type of the limit. So in that case, the multiple tasks which are to be computed and that has to be taken into the account with all those type of the constraint. The further this load balancing techniques of this optimized fuzzy load balancing we have computed, and in that the similar type of the work we have gone through with that another example. So without using the another busy machine. So in this, the extra overhead which has to be computed by the controller to compute and making the decisions. In that case, the rule base of this fuzzy base that can be assigned, and the task can be uh, given to them, and that is to be marked over there that without making a separate space for this, and the request of the other task that can be made and the task can be assigned. So it is the another way of reducing the overhead to the controllers to assign the task and making that the task that need to be scheduled, but that the threshold pertaining to that minimum this much of the threshold is required to compute that, and the task is being given, and that task once it is given, that would be updated within that the same list, and based on those similar type of the scenario which I had discussed, the values pertaining to that making the decisions are mentioned over here in that the fuzzy um, graph, where that values of the high, minimum, low, medium, and the very high, with that the multiple membership functions. So in that case, the variations of that this can be there. So the optimized solutions would be there in that the middle part of that ought to be high to give this better optimal solution pertaining to that. It would have to perform that average performance. So the if the memory is maximally available, hard disk space is maximally available, the computation time is maximally available, I can should go for that. If the memory is minimally available and the hard disk space is not there and the computation time overhead is taking there, in that case, that entire based on this, I'll have to create the rules, and the larger number of the rules, larger set of the rules, the better that optimization would be. And in that case, we have gone through up to 75 number of that rules by making this multiple constraint. And again, this optimized load balancing technique is compared with the first come first serve and the shortest job first. So again, in this case, this OFLB is giving us that near to that optimal solutions pertaining to that the job scheduling algorithms in that shortage of first. So having said that, we can say that the optimization of the system can be done while making the use of the resources in an efficient way pertaining to that the various type of that approaches we require to make, and in that the existing approach where that heuristic part that ought to be taken, other ways are that the fuzzy inferences way, which is also referred to as an intelligent way of assigning the resources in a proper and efficient way, would give us that a better and optimized solution. So having said that, I stop and I hope that you would be able to understand that in this is multiple ways of assigning the task and allocating the resources and using of the machine in the different way in the static and dynamic approach, and the intelligent way of a fuzzy rule based technique, which is also referred to as a fuzzy inferences based resource allocation, would give us that better and optimized way. So thank you very much for bearing with me, and I hope that you would be able to understand the basic of this load balancing in the cloud-based networking environment. Thank you. If you have any question, please ask.